History remembers the headlines. We find the bylines. This is the Unsung. April 25, 1953. The prestigious science journal Nature publishes 3 papers that will forever change our understanding of life itself. One of them, written by 2 young researchers named James Watson and Francis Crick, contains an elegant, beautiful, and now famous model, the double helix structure of DNA. In a small footnote, they acknowledge being stimulated by some unpublished work from other researchers. That's a very polite way of saying their breakthrough depended on it. That unpublished work, the key that unlocked the entire puzzle, belonged to a 33-year-old scientist named Rosalind Franklin. History remembers this moment as Watson and Crick's triumph. They became icons, Nobel laureates, the faces of modern genetics. But the raw data, the single piece of evidence that guided them directly to the finish line, come from Han Ten-Ray, photograph taken by Franklin. A photograph so sharp, so clear, that Crick himself later admitted it was the key. So, how did this happen? How was Rosalind Franklin, the woman who captured the literal blueprint of life, effectively written out of the story for decades? Let's get one thing straight. Rosalind Franklin was not a junior lab assistant. She was a powerhouse, an established expert in her field. Educated at Cambridge, she was a master of a fiendishly difficult technique called Think of it like taking a picture of something you can't see, bouncing X-rays off its molecules, and then doing some incredibly complex math to figure out its shape. It's part art, part physics, part sheer grind. And Franklin was one of the best in the world at it. In 1951, she was recruited to the biophysics unit at King's College London, a top-tier institution. Her specific mission: to study the structure of DNA fibers. She was the perfect person for the job, but her situation was far from perfect. The culture at King's was notoriously unwelcoming to women. She was barred from the senior common room, the university's equivalent of a lounge where male colleagues would socialize, debate, and forge alliances. She was often frozen out of the informal conversations where so much of science really happens. To make matters worse, her professional relationship with her colleague, Marie C. Wilkins, was a disaster from day one. There was a fundamental misunderstanding about their roles. Wilkins, who was already at King's, assumed Franklin was being brought in to work as his high-level technical assistant. Franklin, who was recruited as an independent research lead, rightly saw herself as his peer, running her own project. This tension and lack of communication would have devastating consequences. So, what exactly was Franklin's pivotal contribution? It was 2 things, really: her incredible technical skill, and one single, perfect image. First, the technique. Getting a good X-ray picture of DNA was notoriously hard. The DNA samples had to be prepared into incredibly fine, perfectly aligned fibers. Franklin was a perfectionist. She expertly prepared and hydrated her DNA samples, creating fibers that were vastly superior to what others had managed. This wasn't just a minor step. It was the foundation for everything that followed. Better samples meant better pictures, and that leads us to the image. In May of 1952, working with her PhD student Raymond Gosling, Franklin produced what is now known simply as Photo 51. This X-ray diffraction image was stunning. It was a leap in clarity, unlike anything seen before. To a trained eye, like Franklin's, it was a treasure map. It showed an unmistakable X shape running through the middle, the classic signature of a helix, a spiral staircase. More than that, the specific spacing of the dots and smudges on the photo allowed for precise measurements of the molecule's dimensions: how wide the spiral was, how often it repeated. Now, here's where the story takes a turn. In January 1953, Marie C. Wilkins, Franklin's colleague, did something that is, by any scientific standard, completely out of line. Without Franklin's knowledge or permission, A showed Photo 51 to a visiting American researcher, James Watson. Watson, who had been struggling to build a correct model of DNA, later wrote about that exact moment. The instant I saw the picture, my mouth fell open, and my pulse began to race. He immediately recognized what he was looking at. The helical pattern was undeniable. But that wasn't all. Around the same time, Watson and Crick also gained access to an internal research report written by Franklin, which contained all her detailed measurements and analysis from Photo 51. Armed with her perfect image and her precise calculations, the final pieces of the puzzle clicked into place for them. Franklin, meanwhile, was meticulously working through her own data. She was on the verge of solving the structure herself, but the Cambridge duo, having been handed her data, got there first. They built their famous model, raced to publish, and secured their place in history. So, how did this massive contribution get erased from the popular story? It wasn't one single act, but a perfect storm of biases and bad luck. First, there was the great man narrative. Post-war science journalism loved simple, dramatic stories of a lone male genius having a sudden eureka moment. The slow, meticulous, collaborative, experimental work of a female scientist just didn't fit that exciting template. Watson and Crick's flash of insight was a much better story than Franklin's years of painstaking lab work. Then came the Nobel Prize effect. In 1962, the Nobel Prize for the discovery was awarded to Watson, Crick, and Wilkins. Nobel rules are strict. Prizes are not awarded posthumously, and Rosalind Franklin had tragically died 4 years earlier, in 1958, from ovarian cancer at the age of just 37. The Nobel Prize is the ultimate stamp of official recognition. By awarding it to the trio, the history books effectively cemented them as the sole discoverers, pushing Franklin into a footnote. And that footnote was defined for a generation by James Watson's own book. His 1968 bestseller, The Double Helix, was a sensation. It was readable, dramatic, and it turned him into a celebrity. But in it, he portrayed Franklin, whom he called Rosie, as this difficult, stubborn, uncooperative technician who was hoarding her data because she couldn't even understand it herself. It was a cruel and deeply unfair caricature, but it was incredibly influential. For decades, that's who the world thought Rosalind Franklin was. It took years of work by other scholars and historians, like Sayre and Brenda Maddox, to meticulously dismantle that myth and restore her reputation. Underpinning all of this was the simple, structural sexism of the time. Franklin was denied access to the boys' clubs, the informal networks where scientific ideas were kicked around, where credit was negotiated, and where collaborations were formed. She was an outsider in her own lab. Thankfully, the story doesn't end there. The correction has been underway for years. Franklin's own papers, which were published right alongside Watson and Crick's in that same 1953 issue of Nature, are now recognized by scientists as foundational to the discovery. Today, her central role is finally being celebrated. Major universities and research institutes have named buildings, fellowships, and awards in her honor. A Mars rover is even named after her. Her legacy is a powerful one. She was a brilliant, experimental scientist whose work was absolutely essential to one of the greatest paradigm shifts in human history. But she also became the most famous symbol of how systemic bias, ethical lapses, and a hunger for a simple story can obscure the truth and deny credit where it's due. Her story forces us to look closer at the history we've been taught and ask, who else is missing? Who are the other unsung heroes behind the world's greatest discoveries? Let me know your thoughts in the comments below. And don't forget to subscribe to The Unsung for more stories from the bylines of history. Thanks for watching.